All right, let's do this number two. This is 2026 AB Calculus pre-response. This is the area volume question. Just happens to be one we can do on the calculator here. So we're given these two figures. All right, so I've got this. Well, I'll probably have to draw a little bit in figure one and then another figure two here. And we're going, I assume, do some cross sections and rotations and such. Let's read part A. Let R be the region bound by the graph of G, the x-axis, the y-axis, and the vertical line x equals 1. Okay. G, so no F here. G, x-axis, y-axis, and 1. X equals 1. Okay. G, x-axis. Oh, 1, 2, 4. So G is going to type these into Desmos. G is 14x, x plus 12. So a little pro tip here. We want to put divided by first. Okay, let me see if I remember this. 14x plus 12 over x plus 12. So we don't need F yet. I'm going to make this a different color just so I can stand out. So red there. All right, so it said the line x equals 1. I'm going to get that in there. X equals 1. Get that be a different color, maybe blue here. All right, so this is my little area. Then also the x-axis, y-axis. So we know it's this little area here, and we are finding there, right? So I'm going from G down to 0. So it's like this little strip here, a little strip right there. Remember when you do an area, you have a choice. You can either be dx or dy, whatever's more convenient. It's simple. Dx is typical, and it's just simple to say the top of it's always g of x, the bottom of it's always 0. Okay, so I'll go ahead and set up my integral, int, t, and I'm in the x world, so that's clearly from 0 to 1. All right, so 0 to 1. All right, and then we'll say g of x dx, right? Yeah, it's 1.513, so simple enough. Remember, this is like a bunch of little rectangles, is what it is. G of x is this height, wherever you are, that height changes as you move about. So that's the length of the rectangle, and the dx is the width. There's little tiny little rectangles, and you're just adding them up with an integration symbol. Okay, so that's set this part one. Question B. What does question B need? Oh, I'm zooming all over the place here. Not sure what happened to my smart board there. Oh, I went down. Thought I went the wrong way. All right, so region R is the base of a solid. This solid, each cross section, perpendicular to the x-axis, is a rectangle as high as 1/3 times the length of its base in region R. Okay, so that region R is from number 1. Okay, right. But all right, so it's a simple extension. Yeah, it's just all about understanding what's going on. So what I'm doing here is I've got that same strip. It's in perpendicular to the x-axis, isn't it? So I'm still in dx world. So I just take this, and it's like you're looking down, and it actually makes a 3D model. But the height of it's only 1/3 its width. All right, so because we're doing a volume, I need another dimension. This dimension here is going to be that 1/3 of its height thing. So int, again, 0 to 1. So 0 to 1. Okay, then I'm going to do g of x again, g of x. But this time the x, oops, don't need to be up there though. So g of x, let's see. That's only one, 2 dimensions, right? G of x is 1, and so I need to square this. And the reason I need to square it is because the length as it comes off the board, it's 1/3 of the width, and the width is g of x. Now to get the 1/3 in, I need to put it up here, the 1/3, like that. Okay, so 0.792. And again, just for understanding purposes, it's like your volume is 3 dimensions, length times width times height. And those three dimensions are g of x, that's the part you can see right here, 1/3 of g of x, that's the part that the rising off the board, and then dx. Those are my three dimensions, so it summarizes to that. Okay, so 0.792 would be my answer to that one. What was this next one say? Part C, okay, so still figure one the whole time. So this time though, we get to use F, okay, from 0 to A. All right, so let's get F in there. So F is 1 point something, 1.43 is exponential. Let's get F in here. So F of x equals 1.43x plus 0.57. And oh, I didn't make that an exponent. It doesn't look the same, does it? So something's not right. All right, now it looks right. All right, I don't need this x equals 1 anymore. So what I do need are these intersection points, because I need those points done, because it says, make sure I understand the question. Part C, from 0 to A. Yeah, so A is where it intersects, yeah, over there. All right, so from 0 to A. Well, at first, let's see, the purple's on top, that's F. So I'm gonna set up my integral, INT again, INT, and from 0 to 1, we're gonna be in X world again. It's just easier here. From 0 to 1, F is on top. It's top minus bottom, remember. So F of X minus G of X. And we're doing area, so we only need the two dimensions. I don't need to square anything here. Of dx. Okay, so this is going to be this little area on this left little area. And then we have this looks like slightly bigger area where G is now on top. So I'm going to go plus. All right, so what we need to do here is get this point real quick. So I'm going to hit this, I'm going to click here and then hit so I can see it. So plus INT from 1 to wherever that was, 3.256, right? 3.256, and this time G is on top. So I need G on top. G, because the red's on top. The red is G. So minus F of X. And then dx, right? Nothing squared. This is area. All right, so did that add everything up? 0.1, 0.63, 0.632, I guess, for that one. All right, so the last part, we got to use this figure too, right? Let's see what it says. Do I need to type this in Desmos? Let T be the region grounded by the graph of the y-axis, the horizontal line 3.5. Okay, 3.5, and revolved around the y-axis, right? But do not evaluate. Okay, so I don't need Desmos for this. 3.5 is what it says, didn't it? Okay, so this right here is y equals 3.5. This is h of y, and this is x equals 0. So I'm in the y world, and what I want to do, of course, is I want to rotate it so something like this, and it's going to make this sort of cone-looking shape. And this is a bunch of discs. Discs are like thin cylinders. So my volume is pi r squared h. So I need a pi out there, and then integrate so I can add up all the discs. Now I'm in the y world because it says I'm revolving around the y-axis. So what I need then is this strip right there. That's like my radius of each disc. So I need to square that. But since I'm in y world, I'm going to say h of y minus Fortunately, it won't let me erase. H of y minus 0, right? Here's x equals h of y. Here's x equals 0. That's my radius squared. And then my thickness would be dy. Okay, so it's like, here's my pi. There's my r squared. There's my h. And I'm going from clearly 1, and I'm in the y world, to 3.5. Okay, so let me clean that up. That'd be this, from 1 to 3.5. And I can just say h of y squared dy. And that's pretty much it.